My name is Moses Shafer. I did my project on the Bear River watershed. Um, so the Bear River watershed is part of the Bear River Basin, and that spreads through 3 states, Wyoming, Idaho, and Utah. Um, the watershed I'll be focusing on is mainly in Utah, and overall the Bear River is the largest stream in the Western Hemisphere, with an estuary other than the ocean. Instead, its estuary is the Great Salt Lake. The Bear River is also the largest tributary to the Great Salt Lake. And then the section of the watershed that I'll be doing is the Lower Bear River, and that's located in Box Elder County, Utah. So here I have a map. As you can see, it starts up here in Utah, goes through Wyoming, comes back through Utah, and goes back into Wyoming, into Idaho, and ultimately back into Utah, where it dumps into the Great Salt Lake. So the major uses of the basin are pretty vast. It's used mainly for recreation, irrigation, municipal and industrial, and agricultural purposes. Bear River's average discharge into the Great Salt Lake is an estimated 1.5 billion kiloliters, and there are currently plans to extend the use of the massive water supply outside of the basin, and that would create a sustainable water supply for areas in and out of the basin's natural range, since a lot of Utah and everything is more of a desert area because of the rain shadow. Because the basin is surrounded by mountains, it does not have external drainage outlets. So I found a TMDL for the Lower Bear and its tributaries. I found a TMDL for all of the watersheds of the Bear River Basin, but I focused on the Lower Bear because that's the one that dumps into the Great Salt Lake. Its major impairment is phosphorus, and its best management practices are animal waste management, riparian rehabilitation, nutrient management, wetland construction, point source control, irrigation water management, stream bank stabilization, power ramping management, and range pasture management. It's Class 3B. This section is protected for warm water fish and other warm water aquatic life, which includes all necessary organisms in their food chain. And for its 3AD, it's a category 1B. So a little bit about phosphorus. Phosphorus is a limiting agent in streams, along with nitrogen. And too much phosphorus will increase or speed up the reduction of dissolved oxygen, and that's called eutrophication. And this happens because phosphorus is essential to plant life. Here on the next slide, I have a diagram of eutrophication. So here you have the sun, and the sediments from the land block the sunlight, and then you have your sedge grass, and then here the nitrogen, the phosphorus, causes an increase of phytoplankton. And then you can see that there's an algal bloom, and then once the algae die, they decay, and the oxygen goes to decay, and the oxygen goes to the plankton, and the sediments block the sunlight, so a lot of oxygen isn't getting created, and the phosphorus is, like I said, causing eutrophication. And then here are my references.